Hello and welcome to PARC Forum. My name is Mike Friedman. I'm the Vice President of Marketing and Communications here at SRI. We are so happy to have you all here today. This event series was established in 1977 and relaunched last year as a way to bring together some of the most interesting people in the world for a conversation at the intersection of technology, business, and society. Today, I'm very pleased to say that we have almost 1,000 people registered for the event. We have in the past featured Nobel Prize and Turing Award winners, CEOs, journalists, and many other leading speakers and thinkers on a variety of topics. And today's event, of course, featuring Eric Schmidt in conversation with the CEO of SRI, David Parekh, promises to be just a fantastic, fantastic discussion. And thank you all again very much for coming. We do hope that this is a conversation. When you walked in, you received a card with a SRI innovation on one side and some blank space on the other. We invite you to write down any questions that you may have, and we will have people walking down the aisles to collect them periodically, and we'll do a moderated session toward the various points throughout the program. If there are people in the overflow rooms upstairs, there are people there also who can take the cards, and they will share them with me digitally so that we can share those as well with Eric Schmidt and David Parekh. Two housekeeping notes before we begin. First, in the unlikely event of an emergency, please just walk out through the way exactly the way you came in, through these two doors at the back. If you can, walk up toward the right side of the stairways so that if we have any emergency response, they can come down on the opposite side very easily. Second, at the close of the event, after the event is over, please take your belongings with you. We hope that you'll join us at the reception upstairs. Please take your belongings. We'll be closing the doors and locking them. It'll be hard for us to come back here and let you get in if you forget something. Of course, if you do, we'll figure that out. But if you could just take your things, that would be better. Now, again, thank you very much for coming. I am very pleased to introduce you to our CEO for some introductory remarks, David Parekh.
Thank you, Mike. Let me add my welcome to all of you. Delighted you could join us. This is a really special place and time, and as you know, we have a very special guest, whom I'll introduce in a moment. For those of you who don't know SRI, we've been around actually for almost 80 years, spun out from Stanford in the 70s. Known in the early days for things in fintech, such as helping to catalyze the Swift banking network, even FICO scores and ideas along that line. The very first message on ARPANET sent from UCLA to SRI, and then many other things such as the technology with regard to speech, Siri, Nuance, and the technology package that is today a wonderful company, Intuitive Surgical. I was reading an article about the history of ARPANET, and it was a wonderful interview with the two researchers here at UCLA who were doing that work. And the one researcher commented, at the time, we were just trying to get it to work. And you know, to me, it just speaks volumes about innovation, that you put amazing people together working on interesting problems, and at the time you're inventing, you don't always know where it will go. Because often we get asked, what's the next great thing? And we could speculate about 10 or 20 different things, but it's hard to know. And people are just creatively looking at that. Proud to have PARC as part of the team since 23, and you know the amazing things that were developed here at PARC with regard not only to laser printing and Ethernet, but many other technologies, Alto Computer, and those that were commercialized by others. And Sarnoff, also part of SRI in the 80s, things like television, weather satellites, liquid crystal displays, and in a big part, really, DARPA, with Hellmeyer being the one who moved from Sarnoff there to DARPA. And as we think about the future and what we need to do with regard to making people better and our world better, things for curing disease, for national security, for addressing needs in climate and things of that fashion, these are things we're all leaning into. But I think one area where we don't have to guess, will this be a big deal in the future or not, is AI. And so maybe 40 years to be an overnight splash, but certainly it's one where we see Nobel Prize winners and others being recognized for their foundational work. The rapid adoption and acceleration of technologies and all around the world, it's hard to fathom where it will go next. I think of when the iPhone first came out, and I remember reading criticism because it didn't have a keyboard. And you realize people were so focused on something so small, they missed the big picture. And even today, people are thinking, oh, well, it can't do this, or it hallucinates, or things of that fashion. And there will be brittleness, and still is. But what it will change in the future is groundbreaking. Obviously, our guest has thought a lot about it, written about it, and we're going to talk about it in a moment. So let me introduce Eric to all of you. Actually, he doesn't need any introduction to this crowd. You all know him. But Eric, as you know, well known for being an accomplished technologist, entrepreneur, business leader, philanthropist, CEO and chairman of Google from 2001 to 2011, continued as chairman of Google to 2015, and then executive chair of Alphabet. Prior was at Novell and also Sun Systems. But probably one of the things we're really excited about is early in his career, he was at PARC. And so I'm going to give him an opportunity to tell you a little bit about that part of the career, his career. An engineer by training. And a computer scientist, recognized National Academy of Engineering in 2006, and has had a pivotal role in helping this country understand science and technology, serving on the President's Council of Advisors on Science from 2009 to 2017, and also chair of DoD Innovation Science Board in 2016 and beyond. As you know, author of many books, including two that'll be sort of some of the subject matter of today, together with Kissinger and others on the age of AI, and also Genesis, and has, in an amazing way, been an example for all in terms of how he's given back, thinking about philanthropy. He, with his wife, Wendy, have founded multiple philanthropic organizations, including Schmidt Family Foundations, Schmidt Ocean Institute, Schmidt Futures, and most recently, Schmidt Sciences. So please join me in giving an amazing warm welcome to Eric Schmidt.
Thank you, David. Thank you.
So thank you.
You realize this is where it all began.
Yes, I know. We were meeting earlier and walking around the building, and Eric was saying, well, this is where my office was, and could vividly remember different things here. So why don't we start there? Why don't you tell this group a little bit some of the stories I know could take all day, but
yeah,
maybe
I'll try to be short. I don't know about you all, but in your early 20s, everything is seared in your memory. Where is the bathroom? What is the color of the carpet? Who's the boss? The boss is really old. He was 30, right? Right. I mean, just think about being that age. So, of course, I was that age at one point. Jim Morris came to Berkeley, where I was a graduate student, and my advisor said Eric was interesting. Jim liked me and brought me in for a summer job. And I eventually worked here full-time for a few years. And when you see the Alto upstairs, I worked on that Alto. In fact, I just bought one, so I could remember it and preserve it. This was at a time when Xerox was trying to figure out product industrialization, which it was very immature at the time, and they came up with a product called Star, which a number of you in the audience worked on. It was not as successful as the Alto. This is the building where Steve Jobs came and saw the Smalltalk demo and then copied it, allegedly, for the Lisa and the Mac. So when you use a Mac, think this building. When you use any network, think this building. This is where Boggs and Metcalf invented everything. It was slow. It was 3 megabits. It was really fast at the time. The hard drives that we had on the Alto were 5,000 bits. Excuse me, bytes. Excuse me. Okay. How many bytes are on your Android or iPhone for? Android's more popular than iPhone, just to remember. 100 gigabytes. So your phone has what? Do the math. Think about the scale. Yeah. The scale. And so one of the things about this building is the building is the same, but the compounding laws have continued. And I think downstairs was one of the very first fabs. Mm-hmm. This has been lost in history. And the fab was doing very, very low density chips. Carver and Mead were in this side of the building, because I remember them over there. And they designed the VLSI layout systems, which ultimately became the layout systems, for the world. Today, that is a multi-trillion-dollar industry. So if you take the arc of 50 years, right, which is how long the building is in, you can see the point that you made earlier. For me, to give you some color of this, I'm a young man and, long hair, Berkeley, the whole bit, and I didn't have a car, so I had a motorcycle. And I basically lived here, of course, so I had to go home. So I go downstairs, and I go down Foothill, and I get to Foothill and Page Mill. I'm on my motorcycle. It's a big Honda 750K. Right? Remember, I can't lift it. It's too heavy. And it falls over, and I'm thrown off my motorcycle. But I'm okay, and you wake up from whatever happens, and then this Good Samaritan stopped and lifted my motorcycle for me, and I thought, what to do? I said, I'll go back home, which is here. So I show up downstairs, and the security guard, who I know, because of course I'm always here, says, what happened to you? Because I'm covered in blood.
Right.
And they help clean me up, right? And I'm fine, right? So a lot of, whether it's personal, professional, or scalable, it happened in this building. I can go on and on and on.
And I'm sure some would remember who were part of that history. And then as you think about that, was there sort of a secret sauce that made it really special in terms of the way people work together and the dynamism of all of that was key to that innovation?
So remember, at this time, all those books on managing innovation and how to manage tech people had not been written. Tech people were viewed, based on the age of some of the people in the audience, I suspect that you had a similar experience, that we were viewed as unusual. And we were not optimized for anything other than getting the thing to work, right? This, remember, when you use a laser printer, it was invented on the second floor. It was called ears. George Parekh battled with Bob Taylor, who was the head of CSL, brutally. It was my first experience watching politics, which I understand much better now after all the years of managing people. But as a young man, to watch them battle over what they cared about and status and so forth, I remember that the CEO of Xerox came at one point. We had a meeting outside on the parking lot, and they had just bought an insurance company. This was back at the time when the companies, this was the ITT period, where you had to have discordant and uncoordinated revenue streams in your business. It was a terrible idea. Eventually, they got rid of it. Bob Taylor had worked at DARPA in what you know of as DARPA in the Pentagon, and he sort of randomly decided to fund the creation of the internet.
Right.
And when he was doing it, and in the course of it, there weren't that many people working in our area, and he knew them all. So when Parekh hired him here, he just hired them all, and they had nothing else to do. Plus, they wanted to work here, and they all moved here. And the houses were $100,000, and they could, barely afford that. Salaries were low, and so forth. And so it's important to understand that the social-political environment of Silicon Valley is also very, very different. Right? The building is the same. Right? The nerds are the same. Right?
Some of the restaurants are even still here.
The restaurants are still the same.
Yeah, I remember being a grad student here, and being newly married, having graduate student stipend, and it was only enough to pay rent. And you tried to figure out how do you manage all of that, but yet this dynamism of being here with other people interested in developing technology, that was, and you could go outside.
Well, my salary was $45,000 a year, which was enough to live on.
But as a grad student, then, all that. So, and think about the book, and the two books, actually, with regard to AI. Writing it with Kissinger, one might not think, if they hadn't read it, of what's the connection to Kissinger and all of that. Why was he so interested in it? I was sort of marveling at how, at that point in his life, he thought so deeply about this and appreciated the potential impact of AI. How did you connect up together on that?
Dr. Kissinger, obviously everybody knows who he is, was about early 90s when I met him. We were in a strange conference called Bilderberg, which was full of old people celebrating the transatlantic alliance, which I guess is stopping now under Trump. God knows. But nevertheless, Henry was a genuine Atlanticist and had been in this meeting since 1954 when it was presented. It's hard when you live 100 years. You have a lot of history. And so his first question was, so he meets me and he says, "What's wrong with Google? Why can't I get those results changed?" This is a question I'm used to, okay? And I said, "Dr. Kissinger, no, it doesn't work that way." He said, "Well, it should work that way." And I said, "No." And we argued, and I thought, well, this is a good argument. So I invited him to Google, where he presented, this was in our original campus. He got up in front of the employees and said that Google is a threat to human civilization in his Germanic voice. People at Google loved it, okay, because it made everybody feel important. So over the years, what happened was we started to work together just as friends, on national security. And it's amazing when you hang out with somebody that smart how much you accumulate in knowledge. I find myself saying and thinking exactly what he would say. Now, he died a year ago at 100.5, which is remarkable. And the book, Genesis, he finished writing it about a week before he died. Wow. And he was in bed. He couldn't even get out of bed. That was how important the book was. And this was our second book on AI. The first book was called Age of AI, and it occurred before ChatGPT. Now, I thought it was an excellent book, but people didn't really understand it. And then ChatGPT comes out, then everybody understands it. So this notion of language to language, which is what ChatGPT, which is remarkable. It's a remarkable achievement. In his case, he couldn't spell the word algorithm, and he couldn't type. So he's just shall we say, a much earlier generation.
Right.
When he did the China stuff, people don't appreciate this. When he did the China stuff in 1971, there were no phone calls to China permitted. So it was all done with letters through the Pakistani embassy, right? Epistemologically, excuse me. You get the idea.
Yes.
So think about diplomacy in letters, right? Think about today versus today. We don't appreciate how much these things have changed. This is all in our lifetimes.
I know, so fast. And as I was reading the book and thinking about it, I was reflecting on my own, studies and that of my teams, and where, in the 80s, beginning to look at early expert systems with AI, and then all the different winters of AI, and then all of a sudden it seems like for the general public, just a big splash.
Yeah. Well, remember,
November.
expert systems never worked, right? Having worked on it and failed, right? They just didn't work in the 80s. And the big thing that changed, and it's important to acknowledge this, we talk about AI, but what you should really be talking about is scale computing. So I was talking to Elon, of all people, a week ago about Grok 3. And I said to him, how is it that Grok 2 went to Grok 3, which is so good? It's within the leaderboard.
Right.
And his answer was that he had the largest collection of computers doing one model training, because all the other ones are piece-parted out. And that's, again, another data point, that's from a week ago, that the scaling laws of scale compute allow you to do these extraordinary things. And that's why, again, you go back to the arc of the Alto and the Ethernet and so forth, and you just compound it. When do the scaling laws end? Dario wrote a very good paper, which you all should read. It's Dario Amodai, on essentially DeepSeek and scaling laws. And in it, he proposes that there are really three scaling laws going on. The first scaling law is the one that you know about deep learning. Deep learning is what ChatGPT works. And that scaling law says that as you add more hardware and data, you get more emergent behavior, right? And we haven't found the limit of all that. Everyone says there is a limit, but we haven't found it yet. I'm sure there will be a limit, but we haven't found it yet, so I'm joining the club. And remember that the fact that there is a limit does not mean that it's soon. The second one has to do with reinforcement learning. Reinforcement learning is essentially, it's what AlphaGo did, and it's basically what it does is it scores different paths. It looks forward and back and forward and back, and it gives a reward function for that. And then the third one is called test time compute, which is where inside the system, while you're delivering answers, you're also updating your answers. He argues, and I think this is correct, that the latter two are just at the beginning of their scaling laws. So this means that the hardware folks in the room build us more hardware. And those of you that are working on electricity and energy, we need a lot more energy.
Yeah.
The energy demand, I'll give you an example. I spent a lot of time in the Arab world recently and in India. These people are sufficiently insane that they're talking about 1 to 5 gigawatts up to 10 gigawatts data centers. Now let me remind you how big a gigawatt is. The largest dam is about 2 gigawatts, the big ones, right? The really, really big ones, the ones that are too far to drive across. A nuclear power plant is around 1.5 to 2 gigawatts. So we're talking about 2 nuclear plants and 1 data center. That's what we're discussing. And by the way, 1 gigawatt is 45 plus or minus $1 billion of hardware inside of it. So if you have 10, it's a $500 billion.
And then with that kind of scaling, I know lots of people are working on algorithms and other approaches to reduce the energy demands of these clusters, particularly for computing with AI. But then as it becomes more cost effective in terms of energy and also more efficient algorithms, people may use it more. So which curve do you think will win in the end in terms of that aggregate, right?
Well, there's an old saying that Grove giveth and Gates taketh away. And the old timers will know I'm talking about Intel makes the hardware and Microsoft uses it all. And it just seems to arrive just in time. Like if the thing doesn't work, the better hardware comes along and boom, the software people are happy and then they're complaining they need more hardware. I think that's how it works. We're certainly in the middle of that, but we're not at the end. So one scenario, which I think is the most likely, is that we will end up with very large data centers. And yes, there are improvements. Another example is DeepSeek got all this attention, which we can talk about. The improvement in the cost per query and the improvement in cost per query delivery is actually faster on Gemini than on DeepSeek. And this has been well established. So, and the improvement of these now essentially deep learning algorithms is going up at about a factor of 10 a year. So at a factor of 10 a year, each year, you have lots of room for innovation. What DeepSeek did is they came up with a completely new algorithm to do something called SFT. And it's an actual invention. But because they released it in an open source, all of their competitors are just copying it. And furthermore, they based their algorithms, they've acknowledged on Meta's open source model, Llama 400. It's also the case that many people believe that they distilled illegally or inappropriately from OpenAI and so forth. The way you can tell this, if you ask DeepSeek who it is, it says, I'm OpenAI. Right? It learned what it was told. So.
I was thinking back, because there was an article this week about the Transformer paper. Attention is all you need. Seminal work, 2017, 8 Google engineers releasing that. And at the time at the conference, a lot of attention, but probably people didn't realize then the impact it would have and has today. Do you see anything now, immediately on the horizon, that might be of that scale, that sort of resets how we train, how we learn, how we deploy AI?
So I was the chairman of Google when this happened, and I didn't even notice it. That's my fault, right? But that shows you how these discoveries occur, and then you become, all those people left and founded their own companies. One came back, right, in return for $2.5 billion. So it's a good deal. It's a good publishing fee.
And one of them, his dad worked at SRI, I heard. So we were trying to tie that together, too.
So the Transformer paper, for those of you who don't know, was a new algorithm that allowed parallelization in the training. Up until then, the techniques were called CNNs and RNNs, and they were computationally correct, but they were very slow. So the transformers allowed for parallel training in these very, very large networked data centers. With transformers, a lot of hardware is now getting built especially for the transformer architecture. The Google TPUs, TPU stands for Tensor Processing Unit, they're on version 5 with version 6 coming, are under almost all the metrics faster than anyone else's, precisely because they were highly tuned for transformers, as well as the JAX interface that they use. So that's an example where there's this algorithmic improvement, in this case a published paper, that leads to software and then hardware and then a whole ecosystem. So one way to think about transformers is it as durable as CMOS? So in my hardware career, and I'm not as good a hardware person as a software person, I've worked at a number of initiatives that were non-CMOS related. They always fail. And the reason, the fundamental reason is that the economies of scale for CMOS are so profound. If you look at what TSMC is doing with now 3 nanometers moving to 2 nanometers, right, the scale and the precision because of that concentration, right, and they're more than half of the foundry business. So in order for transformers to be replaced, you'd have to have an analogous discovery. I'm one of the funders of one project that is potential, a completely different algorithm. I've been pitched a whole bunch of other ones. So people are trying, but they're not there yet.
Right.
And remember that it is not certain that it gets replaced. CMOS is different now than it was when it was largely invented here by Carver and Mead 50 years ago, but it's fundamentally similar, right? So it may be that transformers just morph into something vaguely similar.
And it also seems that there's a lot of opportunity to develop bespoke models or the power of smaller models. And I wonder whether there's sort of the next expansion might be just like tailoring hardware for the algorithm, to tailor the approaches for particular fields.
I have always believed that, and I'll I'll give you the trade-offs, and then you can decide if you... So remember, I'm an open source person. I participated in open source and Unix before I was here, when I was very young, before it had the name open source. So, I'm used to open source as a model.
Right.
The top models today are basically closed source. Llama is open weight, but everything else is closed. The other ones are closed. There are powerful open source models coming up from below. DeepSeek being an example,
right.
Although in fact it was trained from other models. If you believe that the future is a small number of these big models, right? And I alternate every 6 months, so I'm not sure which phase change I'm in. If you believe that the models will be the small number of very, very expensive, huge data centers and so forth, then we have one set of outcomes. And in that set of outcomes, first, they can be regulated. Literally, you know where they are. The president can order the troops, to take over the data center, all of that kind of stuff, because these things are incredibly powerful from a national security perspective. If you believe that the open source models will get close and broadly available, then we're in a very different world. Because that means that, and this is something I know that SRI is extremely interested in, this question about open versus closed and
how do we provide guardrails? How do we think about what's happening?
This is something you have a huge program that you're doing here. Yeah. So it seems to me that you have to have, today there's no answer to this. What I found is people who work in the closed source companies believe they're going to win. The people who work in open source companies believe they're going to win. But I think a dispassionate view would be to say that we don't know yet. The best case for the closed source models goes like this. When you take a model and you dumb it down, that is, you make it smaller, right. Believe it or not, it loses resilience. It becomes more fragile. So strangely, if you're focused on quality, you should try to get the largest model possible. But the largest models are too expensive to serve, right, computationally.
Correct.
So you have that problem. And if you do build the models, and the term is called distillation, you can take, 10,000 queries against one of the large models, and you can build something which is very, very close to the major model for 1/50th of the price. It's not as robust, but is it functional?
And again, for that particular application.
And we don't know.
Yeah.
So what's going to happen, this is a long-winded way of saying, what does the structure look like? Today, everyone's focused on the equivalent of OpenAI, Anthropic, DeepSeek, Gemini, et cetera.
When you think of the larger models, we were talking about limits a moment ago. So at some point, there's no more data to train on, or much of the data you're training on is processed data.
The industry actually believes that we've gotten all the data.
But I was thinking also about the speed. You were talking about the hardware, and what's amazing with regard to what's happening with AI is not just faster chips, but it's computer architecture, it's the algorithms, it's enabling it to accelerate much faster. I think that was one of the comments in your book when you were writing the afterword of the first book, that it's moving faster even than you anticipated in that first one. And then, so now I think a lot of the conversation is the extrapolation, right? Beyond what algorithm, can it do this? How much power does it use? Where is it brittle? Where does it hallucinate? But fundamentally, how does it change people interacting with the computer? Because I was thinking about the fact that all this was possible because people developed algorithms, they developed chips. Hordes of people had to label data to be trained on. Now people are being hired to basically double-check answers, and is this the best answer in terms of reinforcement? But at some point, that relationship's going to change in terms of people with the tools. It's changing already. It may be in a whole... that's sort of what you were pondering in terms of the book, right?
Let me make a stronger argument.
Yes.
So 50 years ago, in this building, what is known as the Windows, icons, menus, and pull-down interface was invented. I know because I used it.
Right.
I didn't invent it, I used it. That WIMP interface is 50 years old, and it's what you use every day when you're on a personal computer, and there's derivatives of it on the phone. Doesn't it make sense that AI should be able to generate enough bits to have an on-demand interface that's tailored to you for your task, and that the whole notion of raster graphics and fixed bounding boxes and all that stuff that was invented here is completely replaced by storytelling, right? And you start thinking about that and thinking about it, excuse my previous joke, in the person's culture and language and so forth. It's a profoundly different experience.
And I was thinking about that also in terms of how AI is different than analytics, because we think about big data and all of that, and in many of those cases, people are defining the algorithms and approaches that the computer supercharged. But then with all the things that Google had done and related to that, it was not training on algorithms people were providing, but teaching it how to learn. And that's how it won at chess, at Go, and so many other things, and doing protein folding. So how do you see that people interacting with the computer because of that might change beyond just the computer as a tool, as an extension helping do those tasks, but a collaboration of a different type we've never seen
And this,
before.
again, I know is something that you've worked on at SRI for a long time. If you think about it for a while, at least for the next decade, it'll be us plus computers working together. There are scenarios which we call artificial superintelligence, which I can talk about, where that might actually change. But at least for the foreseeable future, it's going to be us and computers. And both the first book and now this book are fundamentally about what does it mean for human identity to be working with an intelligence that is higher than ours in some areas and not as high in others. And we collectively believe that the industry is bringing this stuff forward faster than government, society, civil society can adapt it. You see this, that I can assure you that the people who invented social media, who were largely liberal people from San Francisco, did not anticipate the polarization globally that social media has allowed, because it allowed you to find your friends.
Right. So
And if you're in the narrowing of your society. And the algorithmic boosting that started roughly in 2015 in the various tech companies is shown to be at least correlated, not necessarily causing, but correlated with a rise in mental illness among teenagers, especially teenage girls. There's lots of evidence, or at least correlation of that. Right. So again, when we were all inventing this stuff 20, 30 years ago, it never occurred to any of this. Now, Henry would say, in his German voice, this is because you didn't take any of those classes. And I said, yes, I was too busy programming, right? So his position, which is what the book to some degree was about, was that the solutions to that are not to let the tech bros make these decisions. Sorry for the stereotype, but it's true, that this requires a concerted effort. So the reason we wrote the book was as a call out to say, we need interdisciplinary teams, people who understand history, right, who've not had charmed lives, who understand how people are victimized, especially women and children, and all of that as part of the conversation. What are the appropriate guardrails in those things? AI is both, the benefits of AI are so profound, let me just list them. Curing every disease. I have one group that has decided that in 2 years they can define all human druggable targets. Now, that's a pretty big deal, right? And then the drug industry would then try to drug those targets. Now, we'll see if they can do it, but at least they're ambitious, right? That's a Nobel Prize achievement if they manage to do it. We'll see if they can.
Or multiple.
There are many, many things in biology.
Yeah.
Biology is to AI the way math is to physics, right? In the sense that biology is so complicated, you're going to need AI to interpret it, and that's sort of what's going on. Another way to say it for biology is that sequence prediction, which is what, again, ChatGPT is, deep learning. The way these algorithms evolve is they take a sentence, they take a word out, and then they score whether they put the correct word back in. Any system of physics, math, biology, and so forth that is sequence-based is amenable to those techniques. Mm-hmm. And that's why, for example, AlphaFold and so forth did so well. It's a natural next use of essentially sequence prediction. So things like climate change. Climate change is still occurring, guys, and the development of new energy sources, materials, so forth, better carbon capture are all predated to that. I can just give you example after example.
In terms of what it can do.
And health is the obvious one. What about an AI doctor for the world? Somebody who works with the nurse practitioner. I was in Burma, and I was talking to the guide lady, and I said, I didn't see any hospitals. She said, oh, we don't have any. And I go, well, what happens? I said, oh, well, someone, like if they're really sick. I said, oh, pause. And then she says, they walk into the woods and they die.
Very sad.
Again, it would never occur to me, but that's probably true for a large portion of the population of the world. Why can't we improve that? And the answer is, think about an AI doctor in their language that serves them. Teachers, right? AI, there's lots of evidence of excellent use of AI in the high end, but what about getting the average person's education up, again, in their language and at their level, right, to help the teachers in rural schools? Why do we not have these? All of these things are very powerful. On the negative side, I've worked with the aforementioned usual suspects to work on this question about AI safety, something, again, you've looked at quite a bit. And the core problem today is bio and cyber. Cyber, because it's pretty obvious, right, that if you do enough reinforcement learning, you can eventually find a zero-day exploit, as they're called. So imagine if you have a super intelligence, it can find them all very quickly. We'll see if that happens. And in bio, it turns out it's relatively easy to take existing viruses and modify them so that the various solutions and detections don't work, and then they kill a lot of people. Now, thank goodness this has not happened yet. In the industry, there is a concern that people don't understand this, and we're going to have some reasonably, I don't know how to say this in a not cruel way, a modest death event, something the equivalent of Chernobyl, which will scare everybody incredibly to understand this stuff. We see the possibility. We're doing everything we can to hold this stuff and prevent it. But does it take a tragedy? I mean, Hiroshima and Nagasaki were a tragedy. That's what, and Henry did, as you know, the early, and this is a RAND project, where they invented essentially mutual assured destruction, right, in the 1950s.
Nuclear. Yeah.
So we're going to have to go through some similar process, and I'd rather do it before the major event with terrible harm than after it occurs.
And because you sort of paint that there's both amazing goodness that can come and risk, and often the risk we talk about, and you talk about in your book, is how do we align these systems so that they reflect and protect human values? And also, I thought it was very compelling, the discussion about how productivity will improve, tremendous growth in society overall, but it could have very disruptive effects with regard to equity and balance in terms of opportunity for people and things like that. So maybe one last comment, then we'll take some questions with regard to what are things that can be done along the lines of what you described in the book for the strategy for how do we begin to bound this so that we get the benefit and minimize the risk.
So Henry and I traveled to China to meet with Xi to warn them. This is well before DeepSeek. And as a result, the US and China are having what are called track 2 discussions about this. They're hilarious because the Americans are all on the Zoom, kind of normal Americans, kind of disheveled. And the Chinese are all lined up in a row with their little ties, very organized, very precise. I guess it's how each side shows love to the other. I don't think I'm going to be a very good diplomat. And my co-author, Craig, leads this and does it very well.
Just as long as you don't have to eat shrimp with chopsticks that's not peeled. I had that once when I was over in Beijing.
I think that the real question, first place, maybe this is why, again, I'm not a diplomat. To get the other side to give up something while you're in a race turns out to be really hard. I'll give you an example. One person said, I have an idea. I said, okay, what's your idea? What we're going to do is we're going to have a treaty where each side has a bomb that is on the power supply to the data center, and it can remotely detonate the bomb, not on the data center, but on the power to the data center whenever it's really upset. And I said, good luck, try that. So again, people are thinking about how do you create a situation. I published a piece with Dan Hendricks last week on superintelligence, which I hope you all get a chance to read. And just to finish, this is actually important, let me get it out. The industry believes that in the next little while, we're going to get to the point where we're going to not just have human scientists, but we're going to have AI scientists. So the industry believes that you'll have like 1,000 people at OpenAI, and you'll have 100,000 AI scientists. Now, let's assume these AI scientists are as good as the humans or even better. And this is the slope of innovation. And I already told you it's a factor of 10 per year, which is mind-boggling. What happens when you add a million AI scientists? Presumably the slope goes like this, okay? Now, let's assume, for purposes we're with it, the US gets its act together, highly unlikely, and we're actually doing this. We have all the data centers and so forth, and we've just done this. And China is 6 months behind. Now, everyone here would say, no problem. 6 months, not very much. In network effect businesses, when the slope of growth is this, you never catch up, okay? So this means that when America gets to the point where something new that could completely destroy the country of China occurs, China would have a 6-month latency or more.
Or vice versa.
Or and obviously it's vice versa. So the first thing you conclude is that America should win the race for superintelligence. That's kind of obvious. But the real question is, how do you manage the global partnerships? And one obvious thing to do is say, well, what would China, in the scenario where we're ahead, what is the first thing China would do? The first thing is that they would try to steal the intellectual property. The second thing that they would do is try to modify the weights. That's called an adversarial attack. That might work. So let's say that they don't work, and we're nearing the point of total intellectual dominance, right? That we're building 1,000 Einsteins and 1,000 Leonardo da Vinci's much ahead of them. What are China's options? A preparatory attack, a preliminary attack. So you see in this logic, this is inherently destabilizing to world order. And this is a problem that Henry did not have. He used to, when he negotiated with the Soviets, what he would do is tell them how many missiles that they had in the beginning. Our classified information about their classified information, if you will.
So they knew what we knew.
So they knew, and the negotiations consisted of, well, you have 5,000 of those times this many kilotons, and that's too much, and we have less, but we have more kilotons, and so forth. Maybe we can reduce both numbers. Right. You can't have that conversation in a network effect business. But he told me one day that he went into the meeting, and they're sitting there, all the Soviets are here, and the Americans are here, and he's leading it, and he starts, and immediately they all start screaming at each other on the other side, and one guy is carried out on the Russian side. He was not cleared to know what the Russians were doing, that Henry was about to tell them. Right. Just imagine any of that happening today.
So as we pivot to the questions, do you make a distinction between superintelligence and generalized intelligence?
Yeah, the term that's evolving.
AGI, right.
Yeah, the definition is evolving in the industry, and I should say, by the way, that I call this the San Francisco School. The San Francisco School believes that we'll get to the equivalent of something close to AGI within 3 to 4 years, which, if so, is a huge event. It's like even more important than the founding of Xerox. PARC, excuse me.
But not by much, right? Just a little bit.
I mean, PARC is really important, and that's the arrival of a superintelligence that is equal to the union of
right.
So superintelligence is something greater than that. It occurs when you take the union of everyone's intelligence and you say we're even smarter than that.
Your comment about, how do you counter and someone messing with the weights in your model, it struck me, because I think you also talked about this, that it fundamentally puts at risk our notion of what's true. Because if these models are there providing information, right. And then we're trying to say, okay, how do I even judge if it's smarter than I am, has more information than I have? And then without people even realizing what's affecting their behavior and their thinking, it's based on things that aren't true, right? So how do we
well, I think there's a general problem of misinformation, and these systems are going to get very, very good at lying, right? And a lot of marketing is essentially deceiving or omitting facts, like the card really was broken, but we didn't tell you that kind of stuff. And it's much more serious at the political level. I'll give you an example of military security. I do a lot of military work. There is a law in the US called 3000.09, and it says that a human must be in control of what's going on. So everyone says, no problem. So I'll give you an example. There is a hypersonic missile coming at your boat. You're the captain, and your iPad says, a clock shows up and it says, you have 30 seconds to press this button or you're dead. Okay, that's what it says. How many captains are going to exercise independent judgment and not press that button? 0. So what does it mean for human judgment? And I think just to finish the point, we all are very concerned about human agency. that whether we like it or not, the efficientizing, right, the creation of efficiency systems, if you will, within the network of computing will ultimately affect human freedom. Freedom of speech, freedom of movement, freedom of thought, and so forth. And it doesn't have to be overt. It can be subtle. So for example, you'll give your child the equivalent of an intelligent bear, and the intelligent bear, as they grow up, the bear is their best friend, but let's say the bear has a prejudice. My kid's going to have that prejudice. Was you as a parent didn't even know you had a prejudiced bear.
Yeah.
Right? But there are very, very subtle issues here in society that we have not worked out.
And then your example, I think, points to, we've often thought about autonomous systems and even AI and bounding them by saving certain decisions only for people.
Yeah.
But when you're in a situation where the time cycle for the decision is faster than the human can think, then you have to rely on something that you may not wish to give it the right to make that decision, right? So it's, I mean, that time scale changes so much.
I'll give you an example. In the future, there will be a war between North Korea and the US. North Korea attacks, the US counterattacks, and China shuts the war down. The entire war occurred in 1 microsecond. How? Boom, 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 boom. Supervisory system, shut it down.
Yeah.
Humans can't react that quickly.
I think I like better when we were talking about curing all diseases.
But I think all technology innovations, and again, this is your industry, this is my industry.
Yes.
They are dual use. And I think all of us would agree that the telephone was a great invention. The fact that criminals used telephones was not in the plan. Alexander Graham said, I'm building this for criminals. They need to be able to speak to each other as they're robbing banks. It's not how it works. Right.
So Mike, we covered a lot of ground, may have answered some of the questions, but I'm sure there are many more that we haven't touched on. So why don't you pick a couple that...
Yeah, we have, I mentioned earlier, we have about 1,000 people registered for this event. We have about 1,000 questions right here, so we will do the best we can. There are some students in this room.
And we'll pull up Gemini as well.
Okay. There are some students in this room, so maybe I'll ask 2 that relate directly to the question about AI and education, and they come at it from a very somewhat different perspectives. One is, do you have any concerns about this generation of students and how they're using AI for learning? And maybe perhaps more specifically, what impact will the cuts in Washington to NIH and NSF and perhaps other agencies have on the pipeline for future US-educated AI R&D employees?
So on the latter, this appears to be an anti-science regime. And science is the cornerstone of American exceptionalism. It is science that has allowed us to build the products and the tools and the industries that have so dominated America post-war. Think about the GPS, semiconductors, all the things that I've talked about, built here in America. So the union of reducing the overhead rate to 15%, plus getting rid of foreign students is net negative for all of that. And I think we all kind of obvious that. The first part of the question was?
More about the how AI will affect learning more generally.
So Henry was very concerned about reading. So, he's a historian, a brilliant historian, and his concern is that our next generation of students, who are obviously reading a great deal, but they're reading very short bursts, will not build that internal mental narrative that you get from deep reading books. Now, Henry wrote 22 books, so he clearly has a bias. But we can probably agree that there's much more communications than there ever has been, certainly than when I was here as a student, but that the communication is shorter, shall we say brisker, more to the point perhaps, with maybe less setup and reasoning and so forth. That's a loss. I don't want to opine on how the education industry will fix this, except that the education industry is pretty incompetent at using AI itself, right? That the computer scientists have been the ones that have been building education systems. What do all those education departments in universities do? They do tests of 10 people and they write a paper. Well, why don't we just solve the problem by building a learning machine that learns how you learn with a reward signal and then scale that to every human on the planet. I mean, it can't be that hard, right? It's not like we don't have a lot of teaching going on. We have, 3 million schools in America, some huge number.
And Mike, I might add that I think one of the interesting questions of that type is, if you have a calculator, do you need to know how to add? But then if people don't understand that concept, they don't know sort of how to think if their answer is correct. If you can use AI to write, do you need to know how to write? If you can use it to program, do you still need to know how to code? So you may not need to do the mechanical things, but the understanding and the reasoning somehow we can't lose, because I find so many people who rely on just the answer that comes out of the box and have no way to estimate or judge, does this even make sense?
Another question is about wealth inequity. Wealth inequity has been increasing for many decades in the United States. What will the AI boom and AI itself do to change that? And then parenthetically, the person wrote, it seems that without concerted action, it will only accelerate the trend.
So I agree with the bias of the question. What happens in networked markets, and this is a network market, is a small number of winners get the majority of the profits. You see this, I'll use an example. Look at the globalization of NBA basketball players. Right? Good for them. But now they're global superstars. They make a lot more money than if they were just US stars. It's the same principle. One of the questions I ask the industry is, why are you not building tools that take the average person's wage and increase it by 10%? That's the goal. In other words, that's the objective of the tool. You can do anything you want, but you have to increase their salary 10%. And there are plenty of examples of where you could increase somebody's wage by 10% by automation, for example. I'm very concerned about the inequity portion. I'm not as concerned about the employment portion for the following reason. We're not having enough children. And if you look at South Korea is less than 0.8, you need 2.1. China's down to 1.0. They claim it's 1.1. It's actually 1.0 or below. The US is now down to 1.64, something like that. Everybody is struggling with this. So as long as we're producing fewer humans, the dependency ratio, which is the ratio of people who are working to people who depend on the people working, will be in favor of getting these people more automated. So at the moment, the job problem is not a problem. The way we'll solve the productivity problem of this smaller number of cohort is make them more efficient. This is why the Asia, they're not having any kids at all, best I can tell. They're having this huge automation boom. Korea, China, so forth and so on. Just look at what they're doing, and they're good at it. But I think the inequality is highly likely to get worse for the reasons that the questioner asked.
So what is, a question about misinformation. What is truth? There's more. When new information scales beyond known human information, and the question is a provocative question, aren't we creating reality?
So Henry was very interested in the Move 37 and AlphaGo. The Go game had been around for 2,500 years, and AlphaGo invented a move that had not been seen or at least documented in human history that worked and caused them to win the game.
Yeah, it's like game 2, right?
And he kept saying to me, is that an alien intelligence? I mean, what is that? Right, so I answered it by saying it's an algorithmic derivation of a particular path. That's not what he was looking for. He was looking for, why did it occur there and not with humans? So with respect to the question of truth, at Google, I answered this all day by saying, I have no idea, but we know how to rank people's attempts at truth. As a scientist, I will tell you the reason science works is because of essentially the ability to falsify. So the moment anyone has a science result, everyone tries to see if they can falsify it. And if it's attacked enough times, then it's true. I remember learning about relativity, Einstein's relativity theory, and I thought this is the stupidest thing ever. So I talked to my graduate student friend who did it in physics. He said, I use it every day. It works all the time. So in other words, Eric, you're wrong. So it sure looks like the way we understand truth in science is from repeatability, falsifiability, and so forth. With respect to speech, we're in a situation where people have lost track because the distinction between online and offline is going away because because they live online and offline, and it's quite seamless. They're losing perspective as to what is truth and what are the most important things in your life, your health, your family, the people around you, your safety, your immediate environment. We're sort of losing all of that. And it's made much worse by AI algorithms, because AI algorithms maximize revenue by maximizing outrage.
There is another question in
point.
here that I don't have it right in front of me since there are so many, but it touches on that point, which is there another model for AI monetization that doesn't mention outrage per se, but mentions issues of privacy and trust and similar kinds of things?
Yeah. This is again, these questions are fantastic. We don't know. The digital advertising industry is largely dominated by Google and Meta. They have, we Google have more as a percentage, but between the two is mostly that. And those models are highly efficient, highly optimized, very stable, work really well. The customers are happy, the shareholders are happy. We have not yet come up with a better monetization model for social media. People have done, my instinct is probably more of a direct relationship. So if you look at influencers, they're trying to sell something. So to the degree that the algorithm connects the influencer directly with the consumer and they can monetize that, that's probably a significant improvement. If you look at TikTok, TikTok is derided in the US because none of us use it because we're too old, sorry. But your 18-year-old is addicted to TikTok, and they're addicted to TikTok because it's a different algorithm. It's not a social network algorithm, it's a likes and interest. And if you, because of some things I've been doing, I've had to spend lots of time on TikTok, and which is sort of difficult. And you play with it for a while, and then you change your interest, it immediately switches to your next set of interests using a set of complex metadata. So it sure looks to me like the TikTok model is the most addictive model built in computing science yet, built in China, and that you need to come up with a monetization model that goes with that, and that eventually that model will dominate.
So maybe one or two more questions?
Sure, yeah. So given the pace of change, related questions, what does innovation even mean anymore? And what advice do you have for entrepreneurs and startup founders who are maybe doing one thing today and then their whole world changes tomorrow?
None of this is new. It's just happening faster and people are more vocal. But I've done, 5 waves of technology, 5 waves of startups, 5 boom and bust cycles. Next time I'm going to sell at the top, not the bottom. But people have forgotten. Remember Vine? Remember, or go back to pets.com in 2000. People have no memory for the tragedy of the past. I gave a speech in this auditorium in the late 90s, which I watched recently, and the discussion about what I was talking about is all forgotten, including by me, right? It just moved, and it moved quickly. So that's, I think, how it will play out. Today, as an entrepreneur, you have it easier and harder. When I was doing this, you had to build your own data centers, you had to build your own computers, you had to arrange your own power, you had to give people computers, so forth and so on. We had to wire the networks and so forth. Today, San Francisco and others are just filled with these office buildings first using people on Wi-Fi networks where everything is remote. Cloud-based computing is really an accelerant. And the correct model for cloud-based computing is back-end server running the app, and then an iOS, Android app doing something interesting. And that is the union now with AI applied to it. And that will dominate for a while. So the cost of entry is very low. It's never been a better time. That's the good news. What is the bad news? Is the amount of money in the system means that you have to overpay people who have no proven track record, and they're all very obnoxious about it. And remember that if you lay them off, they can immediately get a job equal or better somewhere else. So don't do that either. And sort of this little bubble that we're in looks like it's a pretty long one in that sense. And the reason is that if you have 10 or 20 of the kind of people I'm talking about, and you apply them to any existing business, you can increase revenue or earnings by 10%, 20%, 50%. So what's the value of that 10% or 20%? It's equal to some fraction of billions of dollars. And so, again, speaking as an arrogant computer scientist, software person, we are worth it, right? Sorry. And we're worth it because when you put us into one of these situations, we can use network computing, AI, and scaling to really affect your business in a way that's positive. One of the things that's not been discussed, because everyone's talking about ChatGPT and so forth, I'll give you is the agentic revolution. Agents are essentially things that do things, and they typically speak to each other in English at the moment. So I happen to like Palo Alto. I want to buy a house. I want to buy land in Portola Valley. There's a couple pieces available. I have an agent that looks for the land. I have an agent that talks to the that looks at the building codes. I have an agent that figures out what architect to hire. I have an agent that does an initial design, gives it to the architecture. I have an agent that goes through the architecture, says it's legal and you're going to like it, then I approve it. I have an agent that selects the contractor, builds the house, and then I have an agent to sue the contractor when he does a bad job. Right? Welcome to California. Now, why did I give you that facetious example? That is workflow in every business. It's workflow in SRI, it's workflow in what I do, it's workflow in every single thing. It's workflow in a university, it's workflow in the military, it's workflow in the government. So when you understand what I just said is transformative to every business process in every institution, at least in the developed world, then you understand why people are so crazy over this.
I was struck by your comment about we haven't figured out how to tune the business models to motivate the kind of outcome that we want with regard to, well, social networking and so on. You talked about advertising. And then the comment about, computer scientists can make a lot of money somewhere else and all that. And, it always sort of amazes me that folks at nonprofits like SRI and so on work here when they could go elsewhere for a lot more money. And the thing that is the common thread is that sense of mission.
Yeah.
And I think if we somehow, can think about that as we think about the technologies, then overlay. I think the book touches on it. We don't have time to get into it, but you and Kissinger and Mundy talk about there's a spiritual dimension to this beyond just the silicon and the carbon and all of that, where there's a set of values that somehow we as a society have to figure out how to put an overlay of that on all that we're doing.
I think one of the pieces of advice is you want to be proud of what you did in your life, right? And there are people who are proud of having made a lot of money for themselves. But I think most people would argue that there are higher purposes, whether it's a religious or God kind of focus or just making the world a better place. If you look at studies of happiness, happiness is highly correlated with having friends and helping others.
Yeah.
So one way to understand it is we need to take the industry, which is today this ruthless competition, which is we all benefit from the competition, and have some higher order goals. Making a better and just society, one where people are not mistreated the way they are now. Vulnerable groups are protected and not eviscerated by this technology. Society has faced these things before. We have this whole notion, in America we have the notion of Bill of Rights. The Bill of Rights are to protect the minority. The Bill of Rights is not for the majority, it's for the minority to keep the majority from harming the minority. And I think that kind of a structure is interesting. Anthropic actually wrote a constitution as part of their attempt to keep their model under control. It's very interesting because it has a whole bunch of these values inside of it to tell the model how to behave. So my guess is that these foundation models, which are today just raw, they just know everything, including all sorts of bad stuff, that they'll ultimately have either a constitution or a governing system or something which reflects this balance of human values, human interests, and power.
Well, maybe we'll end on that point. And you were commenting on accomplishments. And I know when I introduced you, I read a lot of things that I'm sure you're proud of and people recognize you for. I guess being at a research institute, our folks did some research on some of your past accomplishments. And there's one we dug up that relates to you as an engineer, your career here at PARC. That is a thank you for your being here with us.
This is a surprise.
I wanted to
what is this?
Please stand. I wanted to present you
with
a copy and a picture of your patent
that
you developed while here. Software version management system.
Thank you.
Together with Butler Lampson. So building on Ethernet.
So you realize this shows you how good SRI is. I had forgotten I had this patent. No one knew I had this patent. You're the only group that has ever mentioned this patent, and it's the only patent I've ever had. This is a very big deal. Thank you very much, David. Thank you all.
Thank you so much.
Thank you all. Good.
Thank you.